With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi everyone. So today we have the questions from thermodynamics. There are three questions. First, I will read the first question. A sample. Sorry. So first question is: a sample of a gas initially at 27 degrees Celsius is compressed from 40 liters to 4 liters adiabatically and reversibly. Calculate the final temperature. Cv is given to be 2.5 R. So let us do the first question. So we have been given T1, sorry, 1 minute. Yeah, T1 equal to 27 degrees Celsius, which is equal to 300 Kelvin. Similarly, V1 equal to 40 liters and compressed to V2 equal to 4 liters. So we and Cv is given to be 2.5 R. 2.5 R. We know the formula for reversible adiabatic expansion. Tv raised to gamma minus 1 equal to constant. For reversible adiabatic expansion, this is the not expansion, reversible adiabatic process. We have this formula. So from this we can find the Tv raised to gamma is a constant, so we can find T2, the unknown T, from this. But before that we need to know gamma. Gamma equal to Cp by Cv. Therefore, which is equal to, also we have an equation Cp equal to Cv plus R for ideal gas. This is an ideal gas, so we can consider it as Cp equal to Cv plus R. Therefore, Cv equal to given as 5 by 2 or 2.5 R plus R gives us 7 by 2. So it will be 7 by 2 R. That will be the value of Cp. Now gamma equal to Cp by Cv. So therefore gamma equals 7 by 2 R divided by or into 2 by 5 R. R and R will get cancelled. Cp by Cv, this is gamma, so which is equal to 7 by 5. So from this we get gamma and we get T1, V1, V2. Now we can find T2. Therefore we can find T2 here. So we have formula T1 V1 raised to gamma minus 1 equal to T2 V2 raised to gamma minus 1. Therefore T2 is the temperature we need to find, equal to T1 V1 raised to gamma minus 1 by V2 raised to gamma minus 1, which is equal to 300. T1 is 300, V1 is 40 raised to gamma minus 1 is 7 by 5 minus 1 divided by 4 raised to 7 by 5 minus 1. So when we calculate this, we get the value of T2 to be around 753.56. 753.56 Kelvin. This will be the value of temperature. That's the first question. So this was the first question. Now coming to the second question. Second question tells like calculate the maximum work done in expanding 16 gram of oxygen at 300 Kelvin and occupying a volume of 5 decimeter cube until the volume becomes 25 decimeter cube. So we have to do an expansion work. So work has to be done by the system, and therefore it will be a negative work. The value will be negative, and maximum work done means the work done by a reversible process of an isothermal process, reversible isothermal process work done. That's what we need to find. So let us try to calculate that. Work done for reversible isothermal process. That's what we need to calculate. So for that, let's write the formula of work done. Work done equal to minus nRT ln V2 by V1 or V final by V initial. That's the reversible work done formula. So for that we have values. N is we have 16 gram of oxygen. Therefore N will be 16 gram oxygen means 0.5 mole. 0.5 mole because 1 mole of oxygen has 32 gram, therefore 0.5 mole. So N is 0.5, then temperature is 300 and final volume is 25, initial volume is 5 and R we know 8.314. So we can put this, we have N is minus 0.5 into 8.314, temperature is given 300, then into ln V2 is given to be 25, V1 is given to be 5. So when we do this calculation, we get the work done value around minus 2007.13. That should be the work done. So since the work done is by the system, it is coming as negative. So the value is around 2007. That is the maximum work done. So maximum work done equal to magnitude 2007.13 joule. Now coming to the third question. So for the third question we have 10 gram of argon gas is compressed isothermally and reversibly at temperature 27 degrees Celsius from 10 liter to 5 liter. Calculate Q, W, delta E and delta H for this process. So in this we can understand one thing. This is an isothermal process and argon is an ideal gas. So we can consider delta E and delta H as 0. So delta E and delta H as 0. We can write it here. So for the third question, we have delta E equal to 0, delta H equal to 0 as ideal gas consideration. We can consider argon as an ideal gas. And delta or not delta, Q. So Q will be equal to minus W because they are delta E is 0, so therefore Q equal to minus W. So now we want to use the isothermal reversible compression and we have to find the work done. Then we can find the Q easily. So we have been given 10 gram of argon. Therefore from this we can find number of moles of argon. 10 gram argon implies 10 by mass of argon is around 40 gram per mole, therefore equal to 0.25 mole. This is the value of number of moles of argon, therefore 0.25 mole. So we have the value for we have a number of moles N and we have temperature, we have the final and initial volume, so we can find the work done. So work done equal to again reversible compression work, so ln V2 by V1, so which will be equal to minus 0.25 into 8.314 into temperature is 200 Kelvin and not 200 Kelvin, 27 degrees Celsius, which is 300 Kelvin, into V2 is 5 compression, V1 is 5. So this was the value. So now when we calculate, we get the value around 432.121. We get the value around 432.21 joules. So this is the work done during this process. So we have completed these 3 questions, and as I told, so now we have found the value of this work done. So now we can, from this work done, we can find the value of Q. Implies Q equal to minus 432.21 because work and heat are same except the magnitude of work and heat are same. So therefore work heat is just minus W, which is minus 432.21, and that's the value of Q. So now we have found work, heat, and as I told earlier, delta E and delta H are 0 as considering it as ideal gas. So this was the answer for the question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.